When adding integers, it's very important to follow the rules for adding positive and negative signed numbers. So the easiest rule is if the signs are the same, add, and the answer takes the same sign. So for example, I might have these two positive numbers, 6 plus 8. They're both positive, so my answer will be positive. 6 plus 8 is 14. On the other hand, I might have two signed negative numbers. Maybe I have -2 and -7. So I see that the rule says that I add these up, so 2 and 7 is 9, and the answer takes the same sign. So these are negatives, so my answer is -9. Now that makes sense when I model it. So for instance, here's -2, and I add -7 to that. So let's see, 2, 1, 2, 3, 4, 5, 6, 7. And I ask myself, how much do I have altogether? I have -9 chips. Now, the rules for adding integers when the signs are different is a little more complicated. So if there are different signs, I need to find the difference. So for instance, let's say I have 6 plus -8. I notice my signs are different. This one's positive, this one's negative. So I'm going to determine the number with the greatest absolute value. That means which number is the farthest away from 0. This one is. This one has the greatest absolute value. So I'm going to subtract this other number from it, and I'm going to notice that my answer takes the sign of the greatest absolute value. So I'm going to find a difference between 8 and 6. That means I subtract. It's 2. Now the sign that goes here goes along with the sign of the greater absolute value, which is this -8. So this is a -2. And it makes sense when I use my chips. So I have 6 positive chips. And I'm going to take a -8, and I'm going to line them up right below my positive ones so that I can remove 0 pairs. So there's 6, and here's 1, 2, 3, 4, 5, 6, 7, 8. So there's my -8. Now this is +1 and -1. That makes 0. This is +6 and -6. That makes 0. I remove them. What's left is my -2, the greater absolute value, the greater amount.